What's up, guys? It's me, Sir Ernest, and today we're going to discuss the analogy between the equations for translation and for rotation of rigid objects about a fixed axis. So, for example, we have two rigid objects, and the origin is located at their center of masses. So, here we're going to define several parameters related to motion. So, for example, the inertial quantity that we use for translation is mass. So let's call that the mass of your object m. On the other hand, for rotation, the inertial quantity that we use is the moment of inertia I. So let's say this object is rotating about the z-axis. So let's put here z. So if this object rotates about the z-axis and let's say it's rotating counterclockwise, so we now define our omega, wherein omega is our angular speed. So therefore, the angular velocity would be equal to omega k hat. On the other hand, for translation, let's say this object moves towards a positive x-axis. So in one dimension, it would look something like this. So let's say this is your velocity. So this is v along x. So for translational motion, the product between the mass and the velocity is called the linear momentum. This is px and is equal to m times vx. So here we're just doing away from the vector quantities because the motion for translation is along one direction, that's the z-axis. Now for rotation, the momentum associated for rotation is called the angular momentum. And this is expressed as Lz equals Iz omega, as discussed previously. So for the force exerted on this object that causes this object to change motion in terms of translation, we call that your net force or simply force. And this is written as F along x, for example, and this is equal to mvxi. Now, the object that causes a change in rotation is called torque, and that is written as nz. Z again is the torque about the fixed z-axis, and this is now equal to Iz omega dot. And lastly, the energy associated to motion for translation is your kinetic energy, T, and this is equal to 1 half mvx squared. And for rotation, the kinetic energy is called the rotational kinetic energy, and this is expressed as T equals 1 half Iz omega squared. So you will notice the similarities between the translational parameters momentum, force, and energy between rotation and translation. So that means it's easier now to remember the equations that we use for either translation or rotation. So that's it. That's all for now. Thank you guys for watching, and I'll see you guys in the next video. Bye bye.